All right, so we're on to 8.5, and we're definitely looking at some patterns today. We're all about patterns, but this will make more sense. We're looking at recursive rules. Up till now, we've been using explicit formulas, explicit rules. So we're going to talk about recursive rules. Okay. Now, as long as you can remember that this little n-1 thing, that right there means previous, that was really bad. Nothing good. Previous term. So that n-1 right there, a sub n-1 just means previous term. Okay? If you can get that, then this is actually going to be super easy. Okay? So I'm going to write out some of these on my paper. This one tells us, number one, that a sub 1 is 1. Okay? That means the first term is 1. With recursive formula, they have to give me a term, usually always the first term, for me to be able to get the rest, because recursive keep building on the next few terms. For instance, it says write the first 6 terms. Well, I have to do those in order. I cannot just come up with the 6th term without finding the first 5 terms before it. Okay, so they just build on each other. That's what recursive is. Okay. So I have that right here. Let's see if we can do with number. So I have a sub 1 is 1, that means my first term is 1. They want me to find the first 6 terms. Well, they already started me off with the first one. So the next one I need to find is a sub 2. Well, this right here means the previous term. Well, if I'm looking for a sub 2, the previous term is 1. So I'll plug 1 in right here and say 1 plus 5 is 6. A sub 3 equals, well, again, the previous term. If I'm finding the third term, the previous term is 2, which I just found was 6. So I'm going to say 6 plus 5 is 11. Previous is 4. The previous term is 11 plus 5 equals 17. No, sorry, 16. And 5 equals 16 plus 5 is 1. And then the 6th term, 21 plus 5, you get 26. Okay? I could list those out in order, but I'm pretty found here. That. There's our first 6 terms. Now, they have a couple different ways they write this out. So let's go back and look at number 3. Number 3 looks a little different. It's still basically the same thing. They just use a slightly different form. It says f of 0 equals 3. That means when n is 0, the overall value is 3. Okay? Then f of n equals 4 times f of n minus 1. This is all previous term. Okay? So really all I'm doing here is you're multiplying the previous term by 4. So f of 0 is 3. What comes after 0? 1 comes after 0. Okay? Well, this means previous term. So the previous term is 3. So I'm going to say 4 times 3 is 12. Do it again. 4 times the previous term was 12. 4 times 12 is 48. Next one. 4 times 48. Okay. And maybe you're starting to see a pattern. Like, okay, well, that one's 192. If I multiply that by 4, I'll get 768. And last one, that was 5. We start at 0, so 1, 2, 3, 4, 5, 6 terms. The last one is 3,072. Okay, that's not too bad. Here. All right, and then let's look at it in a slightly different way. They'll write out. What about number 5? They tell me a sub 1 is 1. A sub n equals a sub n minus 1 squared plus 2. Simple this one. This means previous term, and I'm squaring the previous term. So for a sub 2, I'm going to take the first term, put it in there, square it, and add 2. 1 squared is 1. 1 plus 2 is 3. Plug 3 in. 3 squared is 9. Plus 2 is 11. Plug 11 in. 11 squared, I believe, 121. Yes, 121. Plus 2 is 123. 123 squared plus 2. Definitely look up there on this one. 123 squared. 15131. Last one. Very quickly. 2 very so square that number. And then add 2. Wow, I did a quick number. So I square 15131. Add 2. And I get 2, 2, 8, 9, 4, 7, 1, 6, 3. 228.9 million. Okay, and that's number 5. That's the last form that these are written in. So let's see what they're going to do in the next section. They say, well, write the recursive formula for these. So they give me a set of sequences and ask me to come up with the recursive formula for them. So I'm just going to pick a couple different ones. And let's try 7, which is 32, 24, 16, 8, 0. Another one, 11 has fractions. We'll try 11. This is 21, 7, 7 over 3, 7 over 9, 7 over 27. Right, we'll try those two. So how do we go about finding the recursive formula? Well, we're always going to start our formula by writing a sub 1 equals the first term, which in this case is 32. So a sub 1 is 32. Okay. What's our pattern? What are we doing? So it's like a sub n equals, what am I doing to 32 that gets me to 24? And then there. Well, I'm subtracting something. What am I subtracting? Well, from 32 to 24, I'm subtracting 8. So I'm minus 8 to go from here to here. I'm minus 8 again to go from 24 to 16, minus 8 again. So I just keep subtracting by 8. So my rule is I'm going to say a sub n minus 1, meaning the previous term. So I take the previous term and then just subtract 8. And that is my recursive formula. What about 11? Well, 11, I go from 21 to 7. So I could be tempted to think, well, maybe I'm subtracting 14. But if I subtract 14 from 7, no way I'm getting there. So I'm getting fractions, so I'm clearly multiplying by a fraction. Well, 21 to 7, that's dividing by 3. And the only way I can divide by 3 and be multiplying is if I'm multiplying by 1/3. Okay? So I'm multiplying by 1/3 over and over and over again. So I'll say, okay, a sub 1 is the first term. A sub n is, well, I take the previous term. I can write this one of two ways. I can say a sub n minus 1 divided by 3, or I can say 1/3 times a sub n minus 1. Either way, either one of those is correct. All right, we'll move on. It says, well, we give you a rule for it, but in 15 through 20, they give me the explicit rule, and they ask me for the recursive. So I'll pick one or two to do here. This is really only two different types. So I'm going to try 17 and 19. 17, 15, and it's 13 in, and 19 says a sub n equals -2, 7 n minus 1. So let's look at this one. What are my first terms? Well, if I try to plug 1 in for n, what do I get? Well, if I plug 1 in here, I'll get 15 minus 13, which would be 2. So a sub 1 is 2. Write that down. The first term is 2. If I plug 2 in here, what would that give? 15 minus 13 times 2. That gives me negative 11. What if I plug 3 in for n? 15 minus 13 times 3. It gives me negative 24, and it keeps going. What's my fact? What's my pattern? Well, my numbers keep going down by 13. I keep subtracting by 13, which makes sense because of the minus 13 in there. So all I'm doing, my n, so I'm going to say a sub n equals, I take my previous term, subtract 13. There we go. What if I have one like this? Well, if I plug 1 in, I plug 1 and I get 1 minus 1 is 0, and I know anything to the 0 power is just 1. 1 times negative 2 is negative 2. So my first term is negative 2. Well, let's say I plug 2 in. If I plug 2 in, 2 minus 1 is 1. 7 to the first power is just 7. 7 times negative 2 would be negative 14. And if I plug 3 in, negative 2, put that in my calculator, 7 to the 3 minus 1, or second power, and I get negative 98. Okay. Well, is there a pattern? And yes, I keep multiplying by 7, which makes sense because there's my R. This is a geometric sequence. And so I just keep multiplying everything by 7. So I'll say the second a sub 1 is negative 2. And my pattern is I take 7 times my previous term. Okay, so that's how we write recursive formulas. Okay. Well, in the last section, it tells me to write an explicit rule for the sequence. So now it gives them to me as recursive until me it wants the explicit. Okay, so I'm going to pick two of those, and again, I'll do the odds on this one. 23 is a sub 1 equals 14. A sub n equals a sub n minus 1 is 5. And then 25 is a sub 1 is 20. A sub n equals 1/2. And minus 1. Oh. So let's try these. Let's start with 23. Now, the first thing I figure out, what are my numbers? So I know the first number is 14. If I plug 14 in there, I'll get 14 plus 5 is 19. But say 14, adding 5 to that, I'll get 24, and keep going from there. Okay. Well, they're going up by 5. So when I write this as an explicit formula, I'm going to say a sub n equals whatever I'm going up by 5 n. Okay. 5 n. Now there's two ways I could do this. I could just do some trial and error and figure out what this one is. Or at this point in time, maybe I want to remember we have a formula for this. This is an arithmetic sequence. So it's a sub n equals, if I remember this correctly, a sub 1 plus n minus 1 times d, which is a common difference. So if I plug into this, I'll say, oh, a sub n, what's our first term? Our first term is 14. 14 n minus 1 times, what's our d, which is really our slope? Well, it's 5. If I distribute 14 plus 5n minus 5, and then say, well, 14 minus 5 is 9. So this is 5n plus 9. Does that work? Well, let's see. If I plug 1 in, 1 times 5 is 5, 5 plus 9, that is 14. What if I plug 2 in? Does it give me 19? 2 times 5 is 10, 10 plus 9 is 19. Yep, what about 3? 3 times 5 is 15, 15 plus 9 is 24, so yes, that works. So when your patterns that you keep adding by the same number, remember you can use your arithmetic formula. What about 25? I have my a sub n, not a sub 1, that's my first term. What's my next term? Well, I keep dividing the next number by half or multiplying by 1/2. So the next one would be 10, 5, da, da, da. Okay? So we're multiplying by 1/2. Multiplying by 1/2, that's a recursive formula. My recursive formula is geometric means I'm multiplying. My geometric formula is I have a sub 1 r to the n minus 1. Well, let's plug in and see what I get. A sub 1 is 20. R is what I'm multiplying by, it's 1/2. And then I'm just going to leave it in minus 1. Does that in fact give me this? Well, if I plug 1 in, 1 minus 1, 0, and 0 powers 1, 1 times 20 is 20. If I plug 2 in, 2 minus 1 is 1/2, 1/2 times 20 is 10. If I plug 3 in, 3 minus 1 is 2, 1/2 squared is 1/4, 1/4 times 20 is 5. So yes, that does in fact work. And I believe was the last time. Yep, that was the end of that one.